Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at a homework from section 8.3. This is problem number 4. In this problem, they're asking us to take a look at this table, this contingency table, and then we're looking for a confidence interval for some sort of proportion, and let P represent the population proportion for all female students who receive a grade of B on this test. So we're not looking at the grand total. We are only looking at the female students. So this is really what we're concerned about. And in doing so, we will identify that there are N total, 28 total female students in this class. And this is just a summary of a smaller group in this class. And then the number of successes, in this case the success, are those people who received a grade of a B or better, so that our X value is equal to 5 in this scenario. So they want an 85% confidence level, and so we're going to have our alpha is going to be 15%. That's out of 100 minus 85. So we're going to say T sub alpha over 2. By the way, we're looking for the error bound for the proportion, the EBP, is going to be this times what turned out to be standard deviation of a new distribution that we're getting that would make this a normal distribution problem. And if you recall, or maybe if you don't, let me remind you that the formula for that is going to be the square root of PQ divided by N. Now, P and Q are the population proportions and the complement, and we usually can't find that, so we'll use P hat and Q hat, which is going to be what we get, the proportion for the sample that we collected. So that's 5 divided by 28. And then Q would be the complement of that, 1 minus that. Okay, so that's our scenario. And then after we get that, we're going to say our proportion will be the P hat that we would have computed plus and minus the error bound for the proportion that we would compute from here after we get our T distribution. Okay. I'm sorry, we are using the standard normal distribution, so we should be looking at the Z distribution. Okay, now I have some sort of a template in Excel or in Google Sheets. If you were to use a graphing calculator, there will be places to put your X and your N, and then your degrees of freedom, your confidence level. But in this case, we will be using Google Sheets. And here, it's kind of a template, so I encourage you to do this on your own. And then after we put in the X and the N values, everything else will be based on formulas based on the X and N values that you inputted, so that you can continue to use this for future computations for intervals for proportions. Okay. Let's start typing in our values. Our X was 5 and our N was 28. So the sample proportion from here, this is where the formulas begin. I'll say equals, and then I'll say this number 5, and then divided by the N. And so I'm going to get this value, 0.71857, etc. Now I want to find Q hat, so I'm in this Q hat area. I'll click on the cell and say equals, and Q hat is going to be 1 minus the P hat that we just found, and that's going to give me a value of 0.8214. All right, so we got those two values that will help us find the error bound for the proportion. Now our alpha in this case, we want an 85% confidence, so our alpha is 1 minus 85. So I can even type that down, equals 1 minus, and when I say 85, it's actually 85%, which translates to 0.85, and that's going to get the 15%. Now we're going to call on the inverse normal distribution, and so I'll say equals, and then this is a norm dot inv, and then it's going to ask for an x value. Now we don't want to just put alpha here. Remember, it's alpha over 2, so I'll click on alpha and I'll say divide by 2, and so that's going to be half of 15, or half of 0.15. All right, and we're calling on the standard normal distribution, so I'll say comma, the mean for the standard normal distribution is 0, comma, the standard deviation for the standard normal distribution is 1, and then I'm going to close the parentheses. And I can press enter now, but I'm looking at the output. It's a negative number, and remember, we're expecting that to be a negative number, so remember that we want our critical z value to be positive, and so to make that positive, I'll throw a negative sign in front of the norm.inv, and I will press enter. So now I have my critical z value of 1.4395, etc. Okay, let's get to the EBP part, and error bound has this formula. So let me see if I can shrink this a little bit. And so it's going to be z sub alpha over 2 times the square root of p hat q hat divided by n. So I will need to see my values over here. And I'll start this with an equal sign. And then the z sub alpha over 2 was 1.43. Also, I'll click on this cell, and that gives me my critical z value. And I'll hit the star for times, and then everything else will be under a square root. So I'll say sqrt, open parentheses. Now what am I going to have there? I will have the p-value. So if you remember, the p-value is the sample proportion. Oops, harder to see here because of the hints that are obscuring this. So let's see. Here we go. SQRT, the P. Oops, let's get back here. Things happened, so let's restart this. An equal sign, and then the B10 is this Z sub alpha over 2, and then times SQRT. So here we are, SQRT of what? SQRT of the P hat, and then times the Q hat. So those are all in the numerator, and since this is going in sequence, I don't need parentheses around the numerator, but you can throw it in there if you want. So from here, I'll just say divide by, and then I'm dividing by the sample size n. Okay, so just to recap, the first number here, the B10, is the Z sub alpha over 2 times the square root of P hat times Q hat divided by n. All right, I think I'm done. Close the parentheses, I'll say equals, and this is my error bound for the proportion. Okay, finally the lower limit is going to be P hat minus that, and the upper limit is P hat plus that, the EBP that we just found. So from here, I'll say equals P hat minus the error bound, and then I'll press enter, and then I'll say for the next one equals, this is the upper bound, that's going to be P hat plus the error bound, and then I'll press enter. So these are my upper and lower limit values. Okay, so I will go ahead and move this aside and write down the answers based on what we found in our Google Sheets. We have 0.07437, so I'll just put 44, and then there's a point there. And then this is 0.28276, so this will be rounded off to 8. All right, that's it. That is our answer. Now, before I go, I just wanted to point out that all except for x and n, everything and alpha, everything here was kind of set up to be some sort of formula. So if for some reason you want to change your alpha, say your alpha, you want to change that to be 0.05, and if you press enter, you'll see that the upper and lower the EBP and the upper lower limits will also change. And then if you want to do a totally new problem, say you wanted to find the males who got an A in this class, so that would be 15 out of 25. So I can just go here and change this to 15 and change the next number to 25, and then you can change your alpha as well. Then you can see these upper and lower limits automatically change. So if you can just copy this down on your own on your Google Sheets or Excel and set it up like this, where you just change these numbers and change your alpha as needed, then you'll be coming out with not just the upper and lower limits, but also the error bound for the proportion as well. Okay, that is your homework help, and that's it. Good luck.